They'll show 2 minutes.
The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon to everyone. Welcome to this, our third in a series of 5 webinars on pavement sustainability. We appreciate you taking the time to join us here today. My name is Kurt Smith, and along with Dr. Tom Van Dam, we'll be serving as the host and moderator for these webinar events. Our topic of focus for today is sustainable strategies for concrete pavements, materials, design, and construction. And we appreciate the opportunity to bring this information to you. This webinar series is sponsored by the Federal Highway Administration and focuses on the information contained in the recently released FHWA publication Towards Sustainable Pavement Systems, a reference document, which can be downloaded at the link shown here. We are presenting a series of webinars over a 5-month period to highlight some of the key aspects of the reference documents, and each of these webinars will be recorded for later posting on the FHWA website. In fact, Webinar 1 has now been posted to FHWA's website and is available for viewing and downloading. Webinar 2 is expected to be posted shortly. The formal presentation part of the webinar is scheduled to go for about 1 hour and 40 minutes in order to allow about 20 minutes for questions at the end of the webinar. Please submit your questions using the chat box feature, and we will try to get to as many as we can through at the end of the broadcast. You can submit questions at any time during the webinar, but please be sure to access the drop-down feature in the chat box and select Send Questions to Staff when doing so. We'd also like you to note that we will be providing 2 hours of professional development in the form of PDH certificates for each registered attendee, but understand that these are different than continuing education units. You'll want to check with your local professional licensing agency for applicability of PDH credit for your specific situation. As I mentioned, this is our 3rd presentation within the webinar series. Today's webinar is on sustainable strategies for concrete pavements, materials, design, and construction. Our speakers for today include Gina Ahlstrom with the FHWA, Tom Van Dam with NCE, John Harvey with the University of California, Davis, Jeff Raisler with the University of Illinois, and Mark Snyder, engineering consultant. Again, my name is Kurt Smith, and along with Tom Van Dam, we'll be serving as the moderators for the event. So now let's begin our webinar by hearing first from Gina Ahlstrom, who will be providing some background information on FHWA's Sustainable Pavements Program. Gina?
The U.S. DOT is committed to advancing sustainability in all aspects of transportation. Secretary Anthony Fox signed a policy statement in June of 2014 that demonstrated this commitment. We are encouraged to consider sustainability in our policies, operations, investments, and research. In 2010, the FHWA established the Sustainable Pavements Program. The program goals are to support the U.S. DOT goals for sustainability, increase the body of knowledge regarding sustainability of asphalt and concrete materials throughout the pavement life cycle, and increase the use of sustainable technologies and practices in pavement design, construction, preservation, and maintenance. The first order of business under the program was to define what sustainability in terms of pavements and materials means. It is necessary to give practitioners guidance and clarification on how pavements and materials fits into the broader concept of sustainability. The document Towards Sustainable Pavements, a reference document, is just that, a reference. It provides guidelines for the design, construction, preservation, and maintenance of sustainable pavements using both asphalt and concrete materials. It educates practitioners on how sustainability concepts can be incorporated into pavements, and it encourages the adoption of sustainable practices. We're focusing on what we can do today to incorporate sustainable practices into our pavements. The document provides a review of current literature specific to pavement sustainability. We had an extensive review of the document with input from many stakeholders. Rest assured that this is a comprehensive document that benchmarks pavement sustainability today and helps us look to improving and moving that benchmark in the future. Sustainability is not one size fits all, and it's a journey and not a destination. With that, I will turn it back to Kurt.
All right, thank you, Gina. We appreciate that background information. We're now ready to move forward and start talking a little bit about concrete and concrete pavements. And to cover concrete aggregates and concrete materials will be Tom Van Dam. Tom?
Kurt, can you hear me?
Yes, I can hear you.
Okay, I just wanted to make sure. Basically, I'm going to talk about materials, basic considerations, move to aggregates, and then we'll talk about cement and concrete materials. First of all, the thing to consider when we look broadly at materials is there's a lot of things to consider. You know, what are the agency's sustainability goals? What are the impacts of using a material once versus multiple times? What are the trade-offs in increasing the use of recycled, co-product, waste materials? These are all considerations that must be looked at. Basically, when you look at, a lot of people kind of directly associate recycling with sustainability, and truly that is a sustainable practice. What we're talking about when we look at these materials are recycled materials are those that are obtained from old pavement and are included in new pavement. So things like RAP, reclaimed asphalt pavement, or recycled concrete aggregates are a really good example. Co-products are things that are from another process, often industrial, but that bring value when we reuse them or use them in a pavement application. An excellent example for that would be slag cement. Something that's a waste would be something that normally would be going to landfill, but then that we ultimately make beneficial use of. And you know, there's a lot of debate whether fly ash is actually a waste material that then is now being used beneficially, or is it really a co-product material. Air-cooled blast furnace slag coarse aggregate is another example of that. So basically, when we look at the use of these recycled co-product waste materials, you know, the things that we need to ask ourselves, is the performance equivalent or even improved? And then maybe a question that often we get pushed into is it slightly worse? I mean, what if it's slightly worse? How do we factor that decision into using this material in a beneficial way? And do these materials have to be transported great distances? Sometimes rules get put in, hey, you have to use a recycled material, but as we'll talk about later, if we're transporting that material a great distance, sustainability advantage is probably lost. And then in some cases, these materials may make it difficult for recycling in the future. And in one example that they're running into in Illinois is sometimes when they're recycling asphalt pavement, and then now using that as aggregate in concrete, which they're doing with fractionated RAP, sometimes they have steel furnace slag in there. which does offer potential for expansion. And so those things have to be considered. Other material considerations: does longer life justify increased material transportation and production-related impacts? And so we know longevity is a really good practice. You'll hear more about that. But how much, what are those impacts to get us that longer life? Does pavement design make the best use of lower impact materials? Are impacts of transporting materials considered? And that will become a recurring theme. Our specifications, and this is very important, protecting owners' interests, or are they a barrier to innovation? And very common barriers that you see are restrictions on the use of some supplementary cementitious materials. And we can also look at construction variability. Sometimes when we push the envelope, we actually increase the variability in construction, and we have to be careful of that. So moving on to aggregate materials, the largest share of mass or volume in the pavement structure is aggregate. They have a relatively low environmental footprint per unit mass, but they are consumed in very, very large quantities, and so that fact alone has an impact. Impact is incurred in mining, processing, and transporting aggregates, and that impact of transportation can be very large. So when we look at aggregates, they can be used in bound materials, asphalt or concrete mixtures, unbound base, sub-base materials. Natural aggregates are generally classified as either being crushed stone or sand and gravels. And then there are manufactured aggregates that we are using in limited degree in concrete pavements, including one that's becoming a little bit more common is lightweight aggregates for internal curing. And then also such things as air-cooled blast furnace slag is a potential waste material that's being used as an aggregate. Typical volumes of aggregates in concrete, it's lower than they are in hot mix or asphalt mixtures, but still 62 to 68% of a concrete mix is typically going to be occupied by aggregate. And so when we look at the industry, aggregates are produced in all 50 states. Millions of tons of these aggregates are produced annually, worth billions of dollars. And so most aggregates are used as construction material, and some are used in the manufacturing of cement. So if you think of limestone that goes into a cement kiln, that would be an aggregate prior to being pulverized and fed into the kiln. So big industry, lots of dollars involved, and lots of impact. When we look at recycled co-product waste materials that are used as aggregates, we have reclaimed asphalt pavement, we have recycled concrete aggregates, we have air-cooled blast furnace slag, and we have foundry sands, all of which may find a role being used in concrete. RAS, recycled asphalt shingles, to my knowledge, has not seen use. And in steel furnace slag, some of it is used, but it can be, it has to be of the right type so that it's not expansive. When we look at aggregates and environmental impacts, energy consumption and greenhouse gases really depend on the source of the electrical power and transportation distance. And then, of course, because of the additional quarrying, crushing, crushed stone is going to have greater environmental impacts than would sands and gravels. Other impacts include things like fugitive dust, water consumption, land use issues, and community impacts. And this is really driving a lot of the location of new quarries away from urban areas. And so these impacts really, as they push these quarries further and further, these aggregate sources further and further from the primary use areas, the transportation distances are increasing, and thus our impacts are increasing. This figure illustrates a couple of things, but these are energy and greenhouse gas impact of different databases from left to right. So we have 5 different sources of data, and the illustration here is that crushed stones, for example, will have higher impact than will gravels and sands. But what's also interesting is depending on whether it's a European database or a North American database, the impact does differ. And so this slide does illustrate both the variability in the type of environmental data that we have, as well as how different sources have different impacts. Basically, what we were talking about before, depending on how you're transporting material, you can see that trucks, about 150 ton miles per gallon. So relatively low compared to moving material by rail or inland towing. And so if we have the option, it's exceptionally good to move things by rail or by inland by barge. Trucks are the least efficient way to move goods. And so as, again, those aggregate quarries or any material source that goes further and further away, recycled material source, the environmental impact increases just by transporting that material. Strategies when we look at improving the sustainability of aggregates, really trying to reduce the use of virgin material over the life cycle. And so that could include basically longer life facilities so that we have to bring less aggregate in, or increasing the use of recycled co-product and waste materials as aggregates. Reduce the impact of aggregates acquisition and processing. That one's more difficult, and the benefits are really less than you get from other ways. And then really looking at transportation. If we can barge or rail, it's an excellent way to go. And in some places in California now, aggregates are coming in from Canada, they're coming in from Mexico, some are even coming in from Asia into ports, and that would seem ridiculous on face value, but in actuality, that's probably environmentally beneficial when you compare to some of the distances they have to transport by truck. An example of an agency that's doing some very innovative things would be the Illinois Tollway. They are committed to recycling 100% of their existing pavements. They are paving two-lift composite concrete, in which they increase the amount of recycled co-product and waste materials in the bottom lift, including wrap, fractionated wrap. They are in-place recycling of existing pavements, and they have evolved their practices here to improve quality. And so they now will do a lot more grading, but keep, as you can see in the picture on the right, where they don't pick up the concrete, take it to a crushing plant, and bring it back. They instead process it on grade. One thing to illustrate with the Tollway, the thing they will tell you is their decisions are economic first and then environmental. And so they have found really, really great economic advantages as well as environmental advantages through their commitment to recycling. Some aggregate issues and future directions. As mentioned, aggregate sources, the proximity to urban centers is increasing, and so it becomes this trade-off between transportation and local community impacts. And so more and more so, we're seeing less aggregate available in the areas where we need it most. There's increasing pressures to use recycled co-product waste materials, and the trade-off there can be with performance. And so we have to ensure that we have very high quality. There's going to be a push for increased use of marginal aggregate materials as the higher quality sources become consumed. And then there's the demand for specialty aggregates increasing to meet specific sustainability goals. And these can include the use of lightweight aggregates for internal curing. Moving on to hydraulic cement and concrete mixtures. Hydraulic cement concrete is the most commonly used material by humankind after water. And so approximately a cubic yard of concrete is used per person per year in the world. Large economic, environmental, social impacts. Society itself is built with concrete, but yet that volume of use does have negative impacts as well. In the U.S. In 2014, we produced about 80.5 million tons of cement was manufactured. That number is expected to go up until we hit our maximum in maybe 2 years, at which point we'll be importing cement again. And in